Hello, this is Mr. Frank, and welcome to I Can Use an Area Model to Determine Probability. So here's where we are in the unit, learning target 11C. It's our last one for the unit, so we'll continue with review, retake, and then our summative assessment. So just a quick review. Area of a rectangle, length times width. We've got area of a triangle, base times height. I don't have a line here for height, but base times height divided by 2. Area of a circle, pi r squared. Area of a trapezoid, there are two bases. They're parallel to each other. Base 1, base 2. Add them up, divide by 2, multiply by height. You might want to do a quick screenshot of this if you don't remember these formulas. You might need them. So let's move on. So when we think about using an area model to find probability, really what we're doing is thinking about if we threw a dart at a dartboard, what's the probability of hitting a certain area? In this case, let's say the certain area was red. Red makes up, it looks like, half of the dartboard. So the probability of hitting red would be 50%. But it won't always look like a dartboard. Sometimes we're going to have other shapes with shaded areas, just like we did when we were finding the area of a shaded region a couple of units ago. Now what we want to do is use the shaded region to find probability of hitting that shaded region. So the way to do this, the way to use an area model, is we're going to find the area of the whole figure. That's our first step. So in this case, it would be finding the area of the entire circle of the dartboard. And then we want to find the area of the shaded region. Now, I'm not going to do it with this dartboard. We got plenty of different slices here. The examples we're going to use in a few minutes are going to be easier than a dartboard because there won't be so many slices. But you find the area of the whole region. You find the area of the shaded region. We know how to do that. We've done that before. Now, to turn that into probability, what we do is we divide the area of the shaded region by the area of the whole figure. All right? Let me say that again. We divide the area of the shaded region by the area of the whole figure. And then we're going to simplify our fraction and then write it as a percent. So here is the formula to remember for probability. Area of a shaded region divided by area of the whole figure. You might want to write this down, just this part here. That summarizes what you need to know on this slide. All right, so let's try it. I put up here the steps we take, just in case you need to refer to it. So let's find the probability that a randomly chosen point on the figure lies in the shaded region. Another way of saying that is, if I threw a dart at this shape, at the big shape with the rectangle in the middle, what are the odds that it's going to hit something shaded? That's what we're going to find out. So our first step, let's find the area of the whole figure. It's a rectangle. So rectangle, length times width, I'm going to multiply 12 meters by 10 meters, and I get 120 meters squared. Now I'm going to find the area of my shaded region. Now the area of the shaded region is all this. So what I can do is find the area of this rectangle and subtract it from the total area. So the area of the smaller rectangle is 12 meters by 2 meters, or 14 meters squared. So now I'm subtracting that from my 120 meters to get the area of the shaded region, which is 120 meters minus 14 meters, which is 106 meters. So now let's look at point 3 up here. Divide the area of the shaded region by the area of the whole figure. So that's 106 divided by 120. I can simplify that to 53 over 60, and if I put that in my calculator, I can turn that into a percent, 88.3 with a bar over it. Percent. The bar over it simply means the threes keep repeating. So it's 88.3333 and so on percent. So that would be my answer in terms of probability of throwing a dart and hitting the shaded region. All right, let's do another one. We now have a square and a circle. So let's find the area of the whole figure. 12 meters times 12 meters. Length times width, 12 times 12. It's 144 meters squared. Now let's find the area of the shaded region, but I don't know how to find the area of the shaded region, but I do know how to find the area of the circle. And then we could subtract that from the area of the square. So an area of a circle is pi r squared, and my radius is 6 meters. How do I know that? Well, let's see. This is 12 meters, which means my diameter is 12 meters, and my radius is half of my diameter. So that's 6 meters. So I'm going to get 3.14 for pi times 6 squared, or 36, and that's going to be 113 and 4/100 meters squared. So that's the area of the circle, but I want the area of the shaded region. So I need to subtract that from my 144 meters, which was the area of the square, and I'm left with 30.96 meters squared. Now remember what I need to do for probability. I need to do shaded region over whole figure. So there are my numbers, 30.96 meters squared. I didn't put the meters squared over 144. I can convert that into a fraction using my calculator. So 30.96 divided by 144, that's going to equal 0.215, and I change that into a percent by moving the decimal place over 2 places to the right and adding a percent sign. And I know we've done that work as well. So that's another example. Now it's your turn. Find the probability that a randomly chosen point in the figure lies in the shaded region. So find the area of the rectangle, find the area of the triangle, and subtract the area of the triangle to find the shaded region, and then do area of the shaded region over area of the whole figure. So pause here and come back when you're done. All right, let's see how you did. So area of the whole figure is going to be 8 feet times 5 feet, or 40 feet squared. Area of the shaded region is going to be base times height divided by 2. Well, that's actually the area of the triangle. And if I find the area of the triangle, I get 14 feet squared. But to find the shaded region, I need to multiply that 14 feet squared from the 40 feet, because the triangle that I figured out is not shaded and everything else is. So I'm left with 26 feet squared. So I do 26 feet over 4 feet squared over 40 feet squared. I could simplify that to 13 over 20. And in percent terms, it's 65%. So here's one for you to bring back to class. So find the probability that a randomly chosen point in the figure lies in the shaded region. So again, find the area of the whole, find the area of the shaded region, do your division, and then turn it into a percent. So pause here and bring your answer back to class. All right, welcome back. Hopefully you got the right answer. You'll see tomorrow when you go back to class. As always, if you can please capture something you learned or were reminded of, and questions that you have. What are they? I'd love to know. Hope you enjoyed the video. Take care.